Section 3 of Unit 6. This session will introduce you to the scientific applications of radioactivity. By the end of this session, you should be able to explain the applications of radioactivity in scientific and environmental studies. Let us look at the scientific research uses of radioactivity. So radioactivity can be used for chemical analysis, for example in the neutron activation analysis. So the neutron activation analysis, as we discussed earlier on, is a nuclear process and it is used to determine the concentration of elements in a vast amount of material. So the radioactive material can be recovered to the same percentage. So because of that, we can estimate whatever amount that we want to recover. Now, to use this NAA, the sample, or in the NAA, the sample will be bombarded with neutrons, causing the element to form radioactive isotopes. Now, when the radioisotopes are formed, we will now employ the information of radioactive decay path for each element and study the spectra of the emission of the radioactive sample, and by so doing we can also determine the concentration of the elements within it. The NAA is applicable in chemistry and also in other fields such as geology, archaeology, medicine, environmental monitoring, and even in forensic science. Let's look at the applications of the NAA. So the NAA is very sensitive, and so it is used to analyze very small elements which are also present in very low concentrations. We can also use it to analyze trace elements. An example include the use of the NAA to detect trace elements in water and even biological materials. Also, in archaeological studies, the NAA can give useful information about the origin of findings according to the fingerprints of the individual elements compositions in their raw material. The NAA can detect up to 74 elements depending on the experimental procedure that is being used, and it has a minimum detection limit of 10 to 7 to 10 to 15 gram per gram, and this depends on the elements and the matrix material. Let's look at the prompt versus delay neutron activation analysis. Now, neutron activation analysis techniques can be categorized into two groups: the prompt gamma neutron activation analysis, the PGNEA, and then the delay gamma neutron activation analysis. In the PGNEA, gamma rays are measured during the neutron irradiation, and so as the neutrons are being irradiated or are used to radiate the sample, the gamma rays that are produced can be measured. But in the delay gamma neutron activation radiations, the gamma rays are measured at some time after the end of the irradiation. Let us also look at instrumental versus radiochemical NAA. So the instrumental neuron activation analysis, the INAA, it can measure more than 30 elements in many sample types without chemical processing, and what it employs is the use of automated sample handling and gamma ray measurements with solid state detectors. It also employs computerized data processing techniques, and all these features helps it to measure more than 30 elements in different samples. The radiochemical neutron activation analysis is that type of analysis where samples are chemically separated after irradiation to remove interferences or to concentrate the radioisotope of interest. These are few self-assessment questions to test your understanding of the session.